Hi there, this is Mr. Alexander, and today I want to talk to you about the independent samples two-sample t-test. And my goal in this video is to show you how to do it by hand and how to double check it on the calculator. So what I have here is I took a random sample of my students. I've got 7 seniors and 7 juniors, and I just counted the number of tardies that they've had this semester. And I want to know, do seniors have more tardies than juniors? Now this is an independent t-test because I have two samples, one of seniors, one of juniors, that are definitely independent. I mean, there's no one who's a senior and a junior. That couldn't be. I randomly selected them, and we're just going to go ahead and assume that it's normally distributed. Actually, we're not. We'll talk about that more in a second here. But the two independent populations are seniors and juniors. And the hypotheses, the null hypothesis, can be written in two ways. It's still going to have a mu in it. The mu of seniors is equal to the mu of juniors. Now this is going to look a little bit like a one-sample t-test because you've got the mu in there, but there's not a claim value in there the way it's written right now. But you can rewrite it, and you might see it written this way, where you subtract the juniors of the other side. So you've got the mu of seniors minus the mu of juniors equals 0. So in a sense there is a claim value, and the claim value is that there is no difference. There's 0 difference between the two. But I happen to think that seniors are more tardy than juniors, and so my alternative would be the mu of seniors is greater than the mu of juniors. And you could rewrite that alternative hypothesis the same way. The mu of seniors minus the mu of juniors is greater than 0. There is some difference between them. I can go ahead and tell you that I selected these randomly and independently. And they're definitely independent because there's, like I said earlier, there's no one who's a senior and a junior. Now, something we have to be aware of, the conditions of the test is randomly selected and independent, and the two samples are independent. But this one, the normal distribution, I can't actually assume that the distribution is normal. Why? Because I don't have a sample size of 30 or greater. Since n is less than 30, then, I can't assume normality. So when I'm writing a conclusion, that might be something to be aware of. So, in order to test this, I need to first identify the degrees of freedom. And the degrees of freedom, at least in this class, will be defined as the first sample size minus 1 or the second sample size minus 1. We'll take the smaller. Now, the sample size for both of these is 7, so it'll be the same, but if one was larger, we would take the smaller of the two and subtract 1. So 7 minus 1 is 6. My degrees of freedom are 6. Now my critical value is going to come from this table, the T table, of course. And since I have 6 degrees of freedom, we're just going to assume that alpha is 0.05. And since it's a one-tailed test, it's greater than, we're going to say that the critical value is 1.943. If I didn't know if there was a difference, if I was like, well, maybe they're different, but I don't know, and the alternative hypothesis was not equal to, I'd go ahead and select the next one. I'd have to take that 0.05 divided in half. But I don't. I've got a 1.943 for the critical value. And so what that means is that my distribution looks something like this. It's my t, there's my 0, here's 1.943, here's the critical region. So I'm going to calculate a t-statistic, and if there's anything higher than 1.943, of course I'm going to reject. So I've got this data, and I want to know x bar 1 sample size, or sample standard deviation for each of them, and I'm going to do that by going to stat edit. I'm just going to type in this data, 12, 6, 6, 9, 7, 4, 6, and I'm going to do stat calc 1 to calculate all these things. And so the mean for seniors, the mean number of tardies this semester is 7.14 with a sample standard deviation of 2.61. For juniors, stat edit 8, 5, 2, 7, 1, 3, 2, stat calc 1 For juniors, the sample mean is 4 with a sample standard deviation of 2.71. So I've got this information here, and now I can start doing this test. First thing I need to do is find the expected variation in sample means, or if you prefer, the standard error. So that's going to be the square root of my senior standard deviation, 2.61, squared, divided by the sample size of 7, plus the sample standard deviation of juniors, which was 2.71, squared divided by the sample size. When you're typing that in the calculator, you're going to want to be real careful, using lots of parentheses. The square root of 2.61 squared divided by 7 plus, still underneath the square root now, 2.71 squared divided by 7. And that should be 1.422. I'm going to use that to get my t-value. So subtract the x-bars, 7.14 minus 4, divided by the standard error. 7.14 minus 4 divided by the standard error. I get 2.21 for my t-value. And since that 2.21 for my t-value falls in the critical region right here, I'm rejecting. I'd say, okay, I'm rejecting the null hypothesis, therefore p is less than 0.05, and seniors are tardy more than juniors. That's what the data says. Now, part of the point of this video is for you to be able to double check this all in the calculator. So I'd like to show you how to do that now, how to get some of this information. It won't give you all the information, and the way we calculate things in OnRamps is slightly different than the way the calculator calculates some things like degrees of freedom. So some of this won't be exactly right, but you'll be able to feel good with your answer because you're double checking. So if I go back to stat edit and I just type in the data again, so I got my 12, 6, 6, 9, 7, 4, 6, and for juniors was 8, 5, 2, 7, 1, 3, 2, and then I want stat over to tests. It's the number 4, stat test 4, 2-sample t-test. Now you got a couple of options here. You can either type in the data and say, okay, the first one's an L1, the second one's an L2, and then say, okay, I think seniors are greater than juniors. Don't select pooled. In AP Stats, talk about the difference pooled and unpooled. For now, just don't select it. But when you calculate it, you get the t-value of 2.211, which, hey, that looks real close to what I've got there. The p-value, which you've got now, we didn't calculate a p-value, but we said it was less than 0.05, and yet, hey, look, yeah, that's less than 0.05. I told you the degrees of freedom are calculated differently on the calculator, so you're not going to be able to double-check this, but our method is actually easier. The degrees of freedom for us is just the smaller sample size minus 1. This is some fancy stuff that you're not going to need to know. And hey, look, there's my x bar 1, my x bar 2, and my sample standard deviations and my sample sizes too. So you can use this stat test 4 to get some information that you might have been harder to get otherwise. Alternatively, instead of doing data when you do stat test 4, if you go over to stats, you can actually type in, like say you were given the mean and standard deviation, you could just type in the mean and standard deviation. Now it's already in here because I told the calculator where the data is, so it wouldn't pulled it. But like say over here, like, okay, what if you only knew that the mean was 7.14 and the standard deviation was 2.61? You could just hard type it in, and it will go ahead and do all those same calculations for you. You get your t-value, you get your p-value, you get the degrees of freedom, which are not very helpful. But you'll get everything else, and you'll get the same answer, 2.21, just like we did before. So that's helpful. It will not give you the t-critical, but you can double-check your t-critical against this p-value. make sure you're getting the same result. Let's really quickly, in the next 5 minutes here, because that's all the time I have, look at this confidence interval thing. So construct a 95% confidence interval to identify the true difference in the population means. Well, that's x bar 1 minus x bar 2. So we said that was, I already forgot, 7.14 minus 4 plus and minus t critical, which it's going to be different than this t critical. This was 1.943, but that was one tail. Now, a confidence interval is inherently two-tailed. So if I'm still dealing with 0.05, I actually need to cut that in half, because that 0.05 needs to go to this side and to this side. So I'm dealing with 0.025, and my degrees of freedom will still be the same. It will still be 6. The smaller of the sample size is minus 1. So instead of dealing with this 1.943, I need to go over the next one. This is my new t critical, 2.447. And I need to multiply that by the standard error, which I already calculated. 1.422, right up here. And so, 7.14 minus 4 is 3.4 plus and minus 2.447 times 1.422 is, let's call that an even 3.48. So my lower bound then, 3.14 minus 3.48, would be negative 0.34, comma, 3.14 plus 3.48. 6.62. So this can happen sometimes. You make a confidence interval and it actually includes 0. So that's my hypothesized mean. So even though I rejected up here, since it was kind of close, since my t value was kind of close to my critical value, this can happen when you make the confidence interval. It'll have 0 in there, so it makes it look like you shouldn't have rejected. But that's just a function of making this two-tailed instead of one-tailed. What I would suggest to you is you could double-check this answer if you're not feeling great about it by doing stat tests, and there's actually a 2-sample t interval. That would be stat test 0. And again, you can just hard enter the data, or you can tell the calculator where the data is, L1 and L2. I'm just going to say, okay, I typed in the data, the 7.14, the 2.61, the 7, the 4, the 2.71. And I want to make a 95% confidence interval, so I want to calculate that. Now, this thing's not going to calculate it exactly the same way we calculate it in OnRamps, and it's mostly because of this degrees of freedom. This t value is significantly different. The calculator has much more degrees of freedom, so it's going to change this 2.447 to a number that's much smaller, which is why this interval is smaller. So this function is not quite as useful, the 2-sample t interval, but I mean, in reality, 0.34 is not that different than 0.04. I'm sorry, negative 0.34. And 6.62 is not that different than 6.23. I just wouldn't use this to get your answers. Just, this is more of like, am I in the right neighborhood? And it's like, yeah, I'm in the right neighborhood, but the calculator is going to calculate the interval significantly differently. So, in conclusion, if you're double-checking your work, do it by hand first. Double-check it by doing stat tests. 2-sample t-test is 4. And then if you're like feeling really brave and you want to do a confidence interval, that's stat tests 0. Okay? Thanks for watching. I hope you watch the next one, which is about the dependent samples or the paired t-test.